Welcome to this explainer. Today, we're diving straight into some truly groundbreaking research by Klickgard and colleagues. We're talking about the physiological demands of modern marathon kayaking. This is actually the very first study to rigorously quantify the exact cardiovascular load, those massive speed fluctuations, and the tactical pacing of world-class endurance kayakers during a major international championship.
We've got a lot of ground to cover. We'll start with the study design, look at paddle and portage speeds, analyze those crucial speed shifts, dig into the heart rate data, and then wrap up with some practical training applications.
All right, part one, introduction and study design.
So, a modern kayak marathon is an absolutely grueling test of endurance. We're looking at a 20 to 30 kilometer flat water race that lasts anywhere from 105 to 140 minutes. But it's not just continuous paddling. The race is broken up into multiple 3.5 kilometer laps, interspersed with 100-meter running portages. During these portages, athletes literally have to jump out of the water and carry highly specialized, incredibly fragile, sleek sprint boats in their modern wing paddles. It demands a highly tactical approach and rapid physiological transitions between going all out in the water and sprinting on land. To give you a sense of the layout, this course design is from the 2022 European Marathon Championships. The crucial areas here are those portage zones. Athletes have to rapidly transition from water to land, navigating through feeding zones and penalty boxes, all with a kayak on their shoulder. A single slip up here, it can literally cost an athlete their spot in the leading wave. To really understand what's happening to the body during all of this, the researchers analyzed an elite cohort of 30 national team athletes. They looked at both men and women across single-person K1 and two-person K2 boat classes. And the data collection was top-notch. Every single athlete wore a chest belt with an integrated GPS sensor sampling at 10 Hz, plus continuous heart rate monitoring at 1 Hz. That gave the team incredibly accurate, high-resolution kinematic and physiological data for the entire race.
Let's move on to part two, paddle and portage speeds.
Right off the bat, we see a statistically significant difference in raw velocity between the sexes. In the K1 class, men hit a mean paddling speed of 13.9 kilometers per hour compared to 12.6 for the women. Peak speeds showed the exact same trend, men reaching about 20.8 kilometers per hour versus 18.7 for women. The portage running speeds followed suit too, which really just reflects the well-established physiological differences in upper body power and VO2 max between men and women. But here's what's truly fascinating. Despite those absolute speed differences, both groups maintained a remarkably constant mean lap speed throughout the entire 2-hour event. It's incredibly similar to the steady-state pacing you'd see in elite marathon runners. They select an initial speed that is perfectly, meticulously calibrated to be sustainable right up until the finish line. Which brings us to part 3, analysis of speed shifts. When we zoom in, the microdynamics hidden within that overall steady pace are wild. Notice those sharp, frequent drops in velocity? Those are the running portages. And look how perfectly the paddler's heart rate profile spikes to meet those intense demands. So, while the lap average looks steady on paper, the race itself is far from a simple, continuous effort. The stroke-by-stroke data shows that elite pacing is highly variable. We're talking relative speed shifts of 5 to 10% happening 26 to 47 times a race. And massive shifts of over 10%, those occur 12 to 24 times. Men in the K1 class actually performed significantly more of these shifts than women. Scientifically, this all comes down to hydrodynamics. Sitting in the wave drag or wash riding of a leading boat saves a ton of energy. But to overtake, you have to break out of that wash, which demands a huge instantaneous surge in power. Plus, the data showed the final 100 meters of every single lap was significantly faster, proving these athletes are engaging in intense tactical sprints just to secure the absolute best position before hitting the portage.
All right, part 4, heart rate and physiology. Let's talk cardiovascular cost.
This might just be the most staggering finding in the entire paper. These world-class athletes sustain a relentless mean exercise intensity of 85 to 91% of their maximum heart rate for over 2 solid hours, 121 to 129 consecutive minutes. That kind of fractional utilization of aerobic capacity is just incredible, and they maintain it regardless of sex or boat type. It completely rivals the physiological strain of an elite running marathon, but remember, this is being driven predominantly by the upper body musculature.
Looking at the zones, an immense chunk of race time is spent in Zone 4, which is 81 to 90% of max heart rate, and Zone 5, which is 91 to 100%. The portages are where athletes get pushed to their absolute limits. The data shows mean relative heart rates spiking to roughly 94 and 95% of max during those brutal overland runs. Now, interestingly, male K2 paddlers spent a lot more time in heart rate zone 3. They averaged about 22% of their race time there, compared to just 8% for the female paddlers. We saw a similar trend in the K1 class too. The researchers hypothesized that spending more time in this slightly lower moderate aerobic zone might actually be the very thing that enables the men to execute those frequent, explosive tactical speed shifts we talked about earlier. It basically creates a small physiological reserve for those anaerobic surges. Finally, Part 5, Practical Applications for Training. Based strictly on this empirical data, the authors suggest a highly specific scientific approach to training. Step 1. Athletes have got to build an elite, high-intensity, steady-state aerobic foundation. You need to be able to hold 90% of your max heart rate for over 2 hours. Step 2. Intersperse that steady state with frequent, violent speed bouts to simulate those 10% plus tactical shifts. And step 3. The cardiovascular system absolutely must be conditioned to handle the rapid blood volume redistribution that happens when you transition from seated upper body paddling to maximal lower body sprinting during a portage. Which leaves us with a pretty compelling final question. If the physiological load during portages routinely pushes athletes into zone 5 heart rates, how does future training periodization need to evolve to perfectly balance elite upper body paddling mechanics with maximal lower body sprint capacity? It is a fascinating, delicate, scientific balance of endurance and power. Thank you for joining us for this explainer on the physiological demands of elite marathon kayaking.